Good morning. It is Wednesday, May 6th. Today I can find missing arcs and angles of a circle using congruent chords intercept congruent arcs and parallel chords intercept congruent arcs. So it's two separate rules. They're both very small. They're both similar in the fact that both congruent chords and parallel chords intercept congruent arcs. So these are kind of the notes here. Congruent chords intercept congruent arcs. So basically, if these chords, remember a chord, we didn't talk about what a chord is. So a chord is just a line segment inside of a circle that goes from one point to the other. So if these chords here are congruent, then the arcs they intercept are also congruent. Again, chords are just line segments that are inside of a circle. And parallel chords, so here again you see chords that are parallel. If the chords are parallel, then the arcs between them are congruent as well. So both congruent and parallel chords both intercept congruent arcs. So in the diagram below, it says that chord AB is parallel to chord CD. So AB and CD are parallel. So if AB and CD are parallel, then the intercepted arcs are congruent. What are the intercepted arcs for AB and CD? Well, the arcs in between those are here and here. So AC and BD must be congruent. I'm going to jot that down. Arc AC must be congruent to arc BD. It also tells me that chord CD is parallel to chord EF. So if these are parallel, then CE and DF must be congruent. So which statement must be true? CE is congruent to DF. I don't know the rest of them. I don't know that AC and DF are congruent. If I take a look at those, AC and DF, these are not arcs that are cut off by the same two parallel lines. AC and CE, again, they're next to each other, but they're not being cut off by parallel chords. And EF and CD, arc EF and arc CD, they don't look the same. There's nothing that's the same about them. Your answer is choice 1. I want you to take a look at number 2 on your own right now. I'll give you a little bit of a hint. It's telling us that chord AB is parallel to chord CD. I know that parallel chords intercept congruent arcs. I'm going to give you about 30 seconds to come up with your answer. Okay, if AB is parallel to CD, then the arcs between them must be congruent. The arcs between them are AC and BD. Choice 1 is your answer. In the diagram below, blah, 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 chord DC is parallel to BA. So DC is parallel to BA. If DC is parallel to BA, I want you to mark off what we know. I'll give you 10 seconds to do that. If DC is parallel to BA, then the arcs between them must be congruent, so I'm going to mark that. Now it's telling me that BCD is 30, and it's asking for angle AOB. So now this question is going to not only incorporate this lesson, it's going to incorporate what we did a couple days ago. So it's giving me angle DCB. What type of angle is angle DCB? Well, DCB is an inscribed angle. And the rule for inscribed angles, again, it's inscribed because it's on the circle. The rule for inscribed angles is that they're half of the intercepted arc. So if this inscribed angle is 30, then the intercepted arc must be 60. And if this intercepted arc is 60, and these must be the same, then this is 60. Now, I'm not there yet. There's a couple different ways to go from here. That's a good thing about these questions. There is more than one correct way to do it. Now, I'm looking at the arcs. If I have a diameter drawn, we said that each half is 180. So, I could subtract from 180 to find that this piece is 120. It's asking for the central angle. Central angle is equal to the intercepted arc, which makes it 120 as well. So we incorporated a lot of stuff there. We incorporated the inscribed angle as half of the intercepted arc. We incorporated that the parallel chords intercept congruent arcs. We used a diameter cuts a circle in half into 180, and we incorporated that the central angle is equal to the intercepted arc. You could have gone a little bit backwards here. Once you had this was 60, you could have filled in this was 60, and then used the linear pair here. So you had options, but basically you're going to find these questions incorporate different rules that we've done, not just one. So number 4 is a little similar to what we just did. I'm going to skip that one. I'm going to have you do it. I'm going to same thing with 5. And I'm going to jump to number 6. In the circle provided, AC is congruent to BD. So we're not parallel now, we're congruent. Not only do parallel chords intercept congruent arcs, but also congruent chords have congruent arcs. So if chord AC, I'm just going to write this here, if chord AC is congruent to chord BD, then arc AC is congruent to arc BD. So I'm going to mark that. So now it says that AB is 20. It says that CD is 60. It's asking for arc AC. Well, if this is X, then this is X. Since I marked it there the same, I have expressions for the full circle, and I know that the full arcs of a circle add to equal 360. So again, you're going to find that each lesson is going to incorporate a lot of stuff that we did before that. So everything we did in the first lesson of this unit, you're going to see a lot in this lesson. So it's very important that you're not just picking and choosing which lessons you're doing, that you're doing them all in order. X is 50, that's what it's asking for, and there it is. So again, when you have congruent chords, you also have congruent arcs, and then you may utilize that into what we did on Monday. I think I'm just going to do one more, and then you'll finish the rest on your own. In the circle provided, AC is congruent to CE. So if chord AC is congruent to chord CE, then I know that arc AC is congruent to arc CE. It's telling me that angle ACE is 80. Well, angle ACE is an inscribed angle, and I know that an inscribed angle is half of the intercepted arc. So if the inscribed angle is 80, then the intercepted arc is 160. It's asking for arc CE. So if arc CE is X, then arc AC is X because I marked it there the same. Again, they create a full circle. So when the arcs complete a full circle, I know that they must add to equal 360. I'm going to give you about a minute or so to try to finish the problem off from here on your own. Okay, so again, because I have expressions for the full arcs of a circle, I know that the full arcs of a circle add to equal 360. I do the algebra, and I end up with x equals 100. It's asking for x, CE, which is x. That's my answer. So the two rules we're talking about today, when I have parallel, that was a little messy. When I have parallel chords, and again, a chord is just a line segment inside of a circle. When I have parallel chords, the arcs in between them must be congruent. When I have congruent chords, then my arcs are congruent. Not the arcs between them, but the arcs outside of them. Whatever the chord is, it's the same for the arc. Chord AC is congruent to chord BD. Arc AC is congruent to arc BD. You're going to also have to incorporate the rules that we learned on Monday. You need to know that the full arcs of a circle add to 360. If you have a diameter drawn, then that half adds to 180. Inscribed angles are half of the intercepted arc. Central angles are equal to the intercepted arc. Your classwork / homework. Your classwork / homework is to finish the worksheet, and you're going to have a quiz due tomorrow, but again, I would do it tonight. It's just going to be a 1 or 2 question quiz on this. I hope everyone enjoys the rest of their day. If you have any questions, reach out to me and reminds. And that's all I got for you. Have a great day.